Okay, so 5.4 is going to be some different types of special types of factoring. Luckily, since I showed you guys the box, we don't really need to worry about all this stuff up here, okay? If you don't do the box, there's just a whole bunch of different types of ways you factor stuff, but luckily, ours is all working the same way. So let's go down at the bottom here, and let's look at these two patterns. So this is going to be a sum of cubes and a difference of cubes. So what we're going to do, and again, these will be something I'm going to have posted during your test and in the classroom. Okay, so you guys don't ever need to memorize these. You just really need to know how they work. And probably one of the biggest things you're going to have to recognize is what a cubic actually is. So on the next page, we're going to have some of these to look at. So if we look at example A, we see 8x cubed plus 27. Now, the more you guys look at these, the more you're going to start recognizing what a cube is. So 8's a perfect cube because 2 times 2 times 2 is 8. Okay, so 2 times 2 times 2 equals 8. Okay, so we know that's a perfect cube. 3 times 3 times 3 is 27, so that's also a perfect cube. So what we're going to look at is what our A value is and what our B value is. Okay, since we had 8x cubed at the top, our A value is going to be 2x, because 2x times 2x times 2x is 8x cubed. Okay, our B value is going to be 3, because 3 times 3 times 3 is 27. So what we're going to do is we're going to pick the sum of cubes pattern. So the sum of cubes pattern reads like this. So A plus B, okay, A squared minus AB plus B squared. Okay, because we've already identified A and B, this is really just kind of a plug-in when you guys are doing this. So the first parentheses is just A plus B. So 2x plus 3. Okay, second parentheses is A squared. So our A is 2x, so 2x times 2x is 4x squared. Okay, minus A times B, so 2x times 3 is 6x, plus B squared, and B is 3, so 3 squared is 9. Okay, the nice thing about these cube patterns is you don't have to worry about signs, those are already taken care of for you. So really the hardest part about this stuff is going to be identifying what your A value is and what your B value is each time. So the more we look at these, we should start recognizing what a cube is. So the second one, so if we look at example B, x cubed looks good, but 2 is not a cube and 54 is not a cube. So what I'm thinking is maybe what we need to do is factor that 2 out of there. So if I pull out a 2, that leaves me with x cubed plus 27. Okay, so x cubed plus 27 looks like one of these special patterns. So A is just going to be x, because x times x times x is x cubed. B is going to be 3 again, because 3 to the third power is 27. So again, it's going to be that same sign pattern as last time, so let's go ahead and follow our pattern. So the first part is A plus B. Okay, and then we get an A squared minus A times B plus B squared. And this is going to be our factor. Okay, the only time you guys need to be looking at these patterns is when you start seeing this cubic stuff. So this x cubed, that's what's going to probably tip you off that it's going to be one of these two cubic patterns. All right, now factoring by grouping. This is another one of those things that we don't need to worry about because we know how to use the box. So since we've got 1, 2, 3, 4 terms, we've got 4 spots on the box, so it would make sense that we would just go ahead and throw this thing right into a box. Okay, the good thing about these is we already have 4 terms and we've got 4 spots. So first thing we're going to do is pull out our GCF just like before. So that'll be x squared. So x squared times x is x cubed. X squared times negative 2 is negative 2x squared. X times negative 9 is negative 9x. So my factors are going to be x minus 2 and x squared minus 9. Okay, if we look at this second one here, so again, let's go ahead and throw it into the box. Okay, now this one's a little bit out of order here. Typically what I like to do is I like to put them in descending order, so 2x cubed minus 2x squared plus a 5x minus a 5. Okay, so GCF, 2x squared. Okay, 2x squared times x. 2x squared times -1, and then x times 5. So factors are x minus 1 and 2x squared plus 5. Okay, down at the bottom here, again, there's this other thing called U substitution when you're doing it, but as long as you guys know how to do the box, you should be just fine on factoring these. Okay, so let's go ahead and do A. Let's throw it right into the box just like we always do. So 81 x to the 4th minus 16. Okay, if we multiply those together, that's going to be 1296 x to the 4th. Okay, I know this seems like kind of a big number, but you know 81's a perfect square, you know 16's a perfect square, so logic is probably going to tell us that 1296 is also a perfect square. So if you go ahead and check that out on your calculator, it's going to be 36 times -36. Now, we also have to split up that x to the 4th, so let's go ahead and give an x squared here, an x squared here, and that kind of makes sense that those would cancel each other out. Okay, going through here, we need to pull out our GCF. Okay, so I believe 36 and 81 are both divisible by 9. Okay, so 9x squared is going to be our GCF. 9x squared. Okay, 9x squared times a positive 4 is going to give me that. 9x squared times a negative 4 is going to give me that. So I have 9x squared plus 4, 9x squared minus 4. Those are going to be my factors. Okay, let's go ahead and look at B. So again, first one goes in, just like always. Last one goes in. If I multiply those together, that's a -21 x to the 4th. Okay, I need multiples of -21 that add up to 4. So that's going to have to be 7 and -3. And again, logically, it makes sense to split up the x to the 4th and x squared and x squared. Okay, GCF, x squared times x squared times 7, x squared times -3. So final factors become x squared plus 7, x squared minus 3. So the rest of these are going to pretty much factor the same way. Let's go ahead on to the next page to look at some of the ones that look a little bit maybe more different to us. Okay, so the nice thing about this page is since we're already doing the boxes, we don't really need to worry about all this stuff. Okay, we can just kind of keep factoring the way we've been factoring. Maybe the only thing we probably need to watch out for is if there's some sort of greatest common factor that maybe we can take out before we start this. Okay, so there's probably not a need to do all this stuff, so let's go ahead and just pick on a few of these problems. Let's look at number 2 first. So with number 2, I'm kind of seeing that a cubed there that's jumping out at me a little bit. Okay, because of that, I'm probably thinking this is going to be one of those cubic patterns. Okay, so for my a value and my b value, I think the b value is pretty obvious because 27 is 3 times 3 times 3. So the b value is going to be 27. Okay, for the a value, 4 times 4 times 4 is 64. So that's going to be 4a. So as long as we follow the pattern of the sum, okay, the first parenthesis is always the a plus the b. Okay, so here's our a, here's our b. So a plus b is just going to be 4a plus 3. Okay, next up comes a squared. So 4a times 4a is 16a squared. Okay, minus a times b. So 4a times 3 is 12a. Plus b squared, which is 9. Okay, so as long as you guys follow that pattern, you should be okay on those. Okay, let's go ahead and look at number 4, because number 4 is a little bit different in that it has a GCF I can take out of everyone. So if you look at all three of those terms, it looks like I could take out an x squared from everybody. And also 4, 20, and 24 are also divisible by 4. So before I even start that one, I'm going to pull out a 4x squared from everybody. So if I do that, that's going to leave me with an x to the 4th for the first term. Okay, it's going to leave me with a negative 5x squared for the second term. And it's going to leave me with a 6 for the third term. And again, if you think about it, multiplying them back, so 4x squared times x to the 4th would be 4x to the 6th. 4x squared times negative 5x squared would still give me this. 4x squared times 6 would still give me this guy. So now that I've taken out the GCF, let's go ahead and look at what we've got left. So we've still got an x to the 4th and a 6. Okay, if I multiply those together, that's 6x to the 4th. And we're looking for two multiples of 6x to the 4th that would give me a negative 5x squared. So if I do negative 3x squared and negative 2x squared, okay, those would work out. GCF is x squared. X squared times x squared is x to the 4th. X squared times negative 3, x squared times negative 2. Okay, thing about GCF is that's just going to carry down every time you factor a little bit more. So we've got now 4x squared is still there. And then my new factors were x squared minus 3, x squared minus 2. And that's going to be our factor. Okay, so let's move on to some more examples on the next page. Now, again, throwing in the equal 0, all that's really going to do for us is it's going to make us have to solve it eventually and find out what x actually equals in the end. So let's just go ahead and take a look at maybe this middle one here, and let's solve that. So before we do that, we know we need to make it equal to 0. So let's go ahead and subtract out the x squared from both sides. So if we do that, so if I subtract out x squared, so that's going to be now x squared minus 4x plus 8 equals 2x. Okay, let's go ahead and subtract out the 2x. So x squared minus 6x plus 8. And now we're equal to 0, which means we can factor it. So just like always, so x squared and 8 makes 8x squared. Multiples of 8 that add up to negative 6 are going to be negative 4x and negative 2x. GCF, x times x times negative 4, x times negative 2. So we've got x minus 4, x minus 2 equals 0, which means we can set them both equal to 0. And then we can solve them. So the first one we'll have to add the 4. Second one we'll have to add the 2. Okay, so again, equaling these out to 0, all that really means is you're going to have to take it one step further and solve it. Okay, so let's go ahead and take a look at this very bottom one. So this one's a little more complicated in that it's going to be an x to a 5th power. However, we do know we should make it equal to 0. So first thing we should probably do, let's just subtract out 14x to the 3rd. Okay, knowing that stuff should be in descending order, okay, we're going to have this. Now, looking at that, I think there's definitely some GCFs we can take out. So it looks like I can pull out a 2 out of everyone. I can also probably pull an x out of everyone. Okay, if I do that, That leaves me with x to the fourth minus 7x squared plus 12. Okay, we want to keep going on this one, so 2x is good, but I think we can probably factor out that little x to the fourth still. So let's throw that into a box. That'll be 12x to the fourth. Okay, two multiples of 12 that add up to negative 7. That'll be negative 4x squared and negative 3x squared. GCF is x squared times negative 4 times negative 3. Okay, so we've done a little bit more now. We've turned that trinomial into two binomials. Now, there's actually one more thing we can still do. This x squared minus 4. Technically, that can still be factored a little bit more because it's going to be a difference of two squares, because x squared is x times x, 4 is 2 times 2. So we could say that's x plus 2, that's x minus 2. The second one looks like it could be, but 3 is not a perfect square, so there's not a whole lot we can do with that. Now, because this thing's equal to 0, okay, there's still definitely some more work that can be done on it. So let's go ahead and set everybody equal to 0, because we know that's what typically you're supposed to do. Okay, so solving the first one, if I divide out 2, x is just going to be 0. Second one, subtract out 2. That's going to work. Third one, you'll add 2. Okay, and then this one, we haven't really talked about it too much, but we should remember from Algebra 1 we could add the 3 over, and then if I square root both sides, that'll be plus or minus the square root of 3. Okay, don't worry about that one too much. We won't be doing that as much. However, what you should kind of notice about this, though, there's 1, 2, 3, 4, 5 solutions. I'm counting the second one twice because plus or minus each count as a solution. And what you should also notice was this was an x to the fifth. Okay, it's not a coincidence that an x to the fifth has 5 solutions. All the x squares we've been doing so far have 2 solutions. X to the thirds have 3 solutions. So typically you can look at the power of something and determine how many solutions it has.